1Integrate is probably the technology that is used in the vast majority of the solutions that we implement with our customers, and it's used to automate a lot of the complex processes around the process of data management. Now, 1Integrate itself is a very high-end rules engine, and in effect there are two major components to 1Integrate. Firstly, you can create rules inside 1Integrate, and rules are designed to interrogate data in some particular way. So in its simplest form, if you look at it being utilized in the data quality process, you will write rules inside 1Integrate that are run against spatial data, and any non-conforming features within that data that don't conform to the business rules that you've written will be flagged and identified. So it's a very good way in that scenario when interrogating the data to identify these non-conforming features inside that data set. So that's the rules in terms of interrogating the data. In addition to that, there are actions. Now, actions are slightly different to rules in the fact that they change the data in some way, shape or form. So if you take that data quality process through, an action would be maybe utilized to change the data or fix the data. So the rules in the first place, I would identify where the problem is. The action would then automatically fix that data. Now, that's a very simplistic way of looking at what the actions might be able to do. It's used for a lot more complex processes, such as automatically integrating different data sets together, or indeed inferring new data from existing data sets. But it just gives you an overview in terms of the two critical components inside 1Integrate. So if we look to sort of summarize the capabilities of 1Integrate, in the first place, a lot of organizations are utilizing it for that data validation process, that utilization of the rules to identify where problems exist inside the data. In terms of data correction, being able to utilize those actions to automatically correct the data and that's been identified to have problems. And in reality, we aren't able to automate 100% of those data quality techniques. It's unrealistic to do that, but certainly we always aim to get to between 70 and 80% automated correction. And then the third element is that data enhancement, so using the actions to change the data in some way, so to integrate different data sets together, to infer new data from existing data sets. The other key aspect of the rules and actions is these aren't hard-coded. It's not, say, scripting language to create these rules and actions. What we've done inside 1Integrate is made it very easy for users to create these rules and actions through simple drop-down menus. Now, why this is really important is we find with our customers the people who best understand their data and therefore best understand what needs to happen to the data are those subject matter experts. But they're not often developers, and therefore their ability to create rules and actions in a coding world is very, very difficult. The nice thing with 1Integrate is because it's these drop-down menus and these rules and actions are extremely simple to create, it means the subject matter experts themselves can create the rules and actions. In terms of what that really enables organizations, and I won't go through every element in here, but I would like to just talk about and highlight two key enablements. The first one is really automation. So as we use rules and actions, we're able to automate a lot of the processes that previously were quite a manual task. And when you look at the concept of data quality or data management or data integration, there are some pretty complex processes in there. So being able to automate those saves a huge amount of time and effort away from them being traditionally manual processes. The other element to it is because rules and actions and 1Integrate enables a machine-driven process as opposed to an operator-driven process, you get a very repeatable and traceable process as we go through. It also takes that idea of human error out. So anybody who is doing a task which they need to complete multiple times, it is only natural that there will be some errors that are introduced into that process. Machines don't work like that. So the nice thing is 1Integrate, you take that sort of user or operator error out of the equation and get that consistent and repeatable set of results. So I'm now going to hand over to Chris, who's going to take you through some of the concepts of how we utilize 1Integrate.
Thank you, Duncan. As part of the 1Spatial consultancy team here, over a number of years we have developed what we call the data quality cycle, which you can see on the screen in front of you. The way this works is that we work with our customers to initially try and understand what data holdings they may have within the organization, the data discovery phase. And from this, what we can do is we can then agree a data quality mission where we'd like our data to be. And from that, we can then go and define some rule metadata, some validation rules, so that we can see where we are in relation to our data quality mission. So we then do a baseline assessment. And based on this baseline assessment, we can then begin to do some master data management. During this cycle, what we can do is we can check the conformance of the data using the validation rules, and then if required we can do some data reconciliation, and we can actually fix the data, and we can keep going round this cycle of checking conformance and doing some reconciliation until we've agreed and met our data quality mission. And at that point we can then certify and publish the data. Now it might mean that the data is not 100% conformant to the business rule, but it's at a level that we all accept. So we might be 95% conformant to a business rule, but we also know where the known exceptions are. So at the end of this process, we have 100% knowledge of the data. We can also call this process fact, pattern, and action. The facts are that we have some data. The patterns are the business rules that we define within that data, and based on the results we can perform some actions to either publish or tidy up the data going forward. So where does 1Integrate sit in your organization? Well, it acts almost as like a cloak over your master data sets. Data that's going into the databases cannot enter those databases until they've been through a set of business rules and have passed those business rules to an acceptable level. So 1Integrate acts as a cloak around your data and protects it from unruly data getting inside. So one of our customer examples is with Google. Google are trying to build an asset management system with a Tririga database at the back end. The Tririga database from IBM is very, very good at asset management, but it's quite finicky in the way that it actually validates its data. So Google are having some of their contractors capturing floor plans for buildings and submitting them to them. They were then uploading this data to the Tririga database, but when they actually looked at the data, a lot of it was missing, and they didn't know why. And what actually happens is that the Tririga database is, as I mentioned, is very good at what it does, but it's finicky about how it validates the data. So in order for a room to be a room with inside a building, it must be a closed polyline that the Tririga database can assign an area to. If that room does not have a closed line, so it's just a set of lines that are joined together, then the database effectively rejects that object, but it doesn't tell the user that the object's been rejected. So in effect, you don't know that it's not there until you go and try and use the data. And what you end up with is a lot less information than you originally thought you were going to get. And at this point, because Google did not know what was wrong with the data, what they were doing for their contractors was effectively sending back the whole data set, saying to them there's something wrong in the data set, and they weren't giving them any clues about what was wrong and where it was. So let's have a look at what we did to help Google and to help the contractors during the supply chain process. So what you can see on the screen is FME Data Inspector showing one of the DWG files that was submitted. And you and I together can make out on the screen what is a room, what is the edge of the building, what's a door, what's a stairwell, and so on and so forth. But the Tririga database can only do that if the strict rules are met by the data that's being populated within it. So let's have a look how the 1Integrate process took place, and we moved through to help fix and modify this data. Switching to our 1Integrate interface, you can see at the top there are a number of tabs. And effectively what we do with 1Integrate is we initially define some data stores, so that's the way that we can connect to a number of different data formats. We then build some rules and maybe some actions, and then we might marry the rules and actions together with action maps. So anything that fails a business rule can be passed into an action for fixing, and we do that via an action map. And finally we have a session, and a session is where we string all of the data stores, the rules, the actions and the action maps together to process the data sets. So if we move to the Sessions tab and click on that, and then if I open up the Facility Management tab and the session there, I can then click on the tasks, and you can see that we have a number of tasks that we're going to carry out for this data. And the first thing I'm going to do is to open the data and read it into the system. So I hit the play button over here on the right, and you can see that the data now loads. Once the data is loaded, we can have a look at what's been read into our temporary cache. So you can see we've got all these different types of objects here, and then I can view the map to have a look at what we can actually see. So if I go to my legend here and I turn everything off and just turn on the rooms, which is what we're interested in, you can see that those rooms do not look anything like the rooms that have been defined in this DWG file here. But this is what the TriRiga database would look for, because these are the only objects that are closed polylines or closed polygons that can be given an area. So what we can do within 1Integrate is to have an initial look at the data. So the next part of the processing here is to check for duplicate objects, making sure that rooms must be closed polylines, and then making sure that doors must be within rooms. So I'll just click the play button and let that run now. So that's now finished, and I can have a look at the results. If I hit View Map again, and if I go to my legend, and I turn off everything and just turn on the rooms and the doors, and then I go to my reports, I can see that if I go to my session and I click on Check Rooms Must Be a Closed Polyline, and then I go to my report, I can see that there are some failures. So if I zoom to one of these failures by clicking on this highlight button here, I can indeed see that there is a broken line here, or a set of lines that form a room, but it's not a closed polyline, so it's not seen as a room. And as a consequence of that, if I then look at the part of the session that say doors must be within a room, and I go back to my report, I can then have a look at doors that are not in rooms, and it highlights the one that we saw just earlier, and the door is in fact is not in a room, although it's inside a set of polylines that make out a room as we can see it. It's not a closed polyline, so it's not a room, so the door is not within that room. So how can we go and fix this data to help that happen and to help clean? How can we go and fix this data to clean it up and move forward? So the next part of the processing is to remove the duplicate features, remove any duplicate vertices, make sure that the rooms are closed, and then revalidate the data to make sure that doors are now within rooms. So I'll press the play button and kick that off. And again, we can have a look at the results. So by fixing the rooms, you can now see that the data is now beginning to look a lot more like this data that we originally received. But these rooms are now closed polylines. So we're now at a stage where we've got some closed rooms that we can do some extra work with now. So what sort of extra work can we do? So what we're going to do now is we're going to look for overlaps and gaps within the data. So within the rooms, are there any gaps between each room? Do the rooms overlap? So we'll just run that process now. And we'll have a look at the results. If I go to my legend, if I go to my session and I check if there's any gaps, and then I go to my report and I highlight any gaps, you can see that there is a known gap here, but we can't see it at the moment. But if I zoom in, and I keep zooming in, we will eventually see a gap forming in the data, and there's the gap. And we can't see it with the naked eye, because if I measure that gap, you can see that it's only 0.025 inches, which is not very big. So we want to fix those gaps and overlaps within the data. So let's go back to 1Integrate and have a look at how we can do that. So we can build topology within 1Integrate, and building topology allows us to snap sides of buildings that are within a tolerance. So we set a tolerance of 1 inch, and then we build the topology and see what we end up with. So I'll hit the play button. So we run it through and then we check the results again. And I have a check for gaps and overlaps. And if I zoom to what's left, you can see that we have this square here, which is a gap that's left in the data. If I measure this gap, the reason it's not been fixed is because it's 3.006 inches, so 3 inches effectively. So it won't get fixed by the topology. So we have a couple of options here. The first option is that we increase the tolerance of the topology to larger than 3 inches, and then it will fix this problem. However, by doing that, 3 inches is quite a big number. We might introduce other errors that we don't want to. So probably the best thing to do here is, rather than just send back to the supplier of the data, so rather than just send back to the data to the supplier and say it's broken, can you fix it, what we can do is we can send back to the supplier a set of objects that we need them to fix and resubmit as part of the process. So the final part of the processing within 1Integrate is to copy that data out to a file. So I'll just do that. And if I go back to my FME data inspector, what we can do is we can send to the supplier something that looks like this, where we've got the two red lines are duplicates that the supplier needs to look at, and there's our little red square there, the square that's of problems. If I just zoom into that a little bit, and then I turn on the original data set, you can see that this little red square is in fact right in the corner of 2 rooms and a stairwell. So if we had increased the tolerance to 3 inches, we could have collapsed this wall here, or collapsed that wall there, or done something very wrong to the data. So in this case, we can send back to the supplier just the things that we were unable to fix. If you remember what I said originally is, when the data was broken from the supplier, they just sent the whole data set back and said it's broken, because the TriRiga database doesn't tell you where the data's broken. So it's a big job for the users. It's a big job for the suppliers to go through that data and work out what's wrong and how to go about fixing it. Whereas what we're doing is we're fixing the data where we can, and then sending them back just the things that they need to repair, and then resubmit to Google.